Hey guys, today we are going to discuss the solutions of today's Leetcode contest, and let's get straight into it. So there's still 30 minutes remaining in the contest, and I was able to solve all the four problems. So I'll just walk you guys through, through the contest. Um, so the first problem. Um, this is an easy problem. It says that we are just given a string word, and so we are just given a string, and a letter in that string is called special if it appears as a lowercase and as an uppercase letter. Then we have to just count the number of special letters in this word. So the idea is pretty simple. You just iterate through the whole string, and you maintain count of lowercase letters, and you also maintain count of uppercase letters in that word. And then you check if the lowercase, for every character, you check that if it has appeared at least once as a lowercase instance, and also if it has appeared at least once as an uppercase instance, right? So the code is pretty straightforward. uh, that's what we are doing over here. Just have an array of counters or frequency however we like. If it's lower, increment the low counter as increment the high counter, and then go through each character and check if its frequency corresponding to low and high is positive, and if it is, then just add the count and return the answer. So that's pretty much it about the first problem. Moving on to the second problem. Second problem is kind of a modification on the first one. It just says that the condition that we solved for in the first problem, it still holds. That is, letter is special if it appears both as lowercase and uppercase in word. And additional condition here is that every lowercase letter should appear before the first uppercase letter. So that means that so if you have a lowercase letter over here, let's say your character is let's say B, okay? So B appears, so this is the first uppercase instance of B, and all your corresponding lowercase instances of B should appear before it, and it cannot appear after it. So a B cannot come over here. So this cannot happen, and this can happen. So if this appears, if this condition holds, this is the first instance, and these are all the instances of B, all small b's. This is the first uppercase instance of B. So if this condition happens, then you just increment the count by 1, count plus equals to 1, because we want to just find the number of characters which satisfy this condition, in addition to the condition that it should appear at least once as a lowercase and as an uppercase instance, as we saw in the first problem. So to do that, you just have to maintain array of positions for uppercase instances, like you f position. So it will show the first occurrence of a particular uppercase letter, and similarly you have to maintain an L position array, which will store the last occurrence of a lowercase letter, okay? And you will just check if L position of B, I'll just convert it to lowercase, should be less than the first position of B in uppercase. So if this condition holds, and your condition in the first problem holds, then just increment the counter. So that's pretty much it for this problem. So going through the code quickly. So I just copy pasted the first code that we submitted over here, and additionally I'm maintaining the last and the first arrays with the positions, and then just check that condition. So first you have to make an array of all the characters that are valid in the first condition, and all the characters that are valid in the first condition, you again iterate on them and you apply the second condition over here, and then you increment the count and just return that count. So for last, we are just doing to like store the last array. To make the last array, we are just storing the latest index index is just the iteration of that position of that character in the word. And to make the first array, we are just storing, if it's like -1, if we are saying it for the first time, just store the index. That's it. So initializing with -1 means that we have not saw it yet, and if we have not saw it yet, then just store it. Then that's just the way we calculate the first array. So pretty simple problem. Moving on to the next one. All right. This was a bit of a tricky problem, and here the problem says that we are given a grid of m columns, I guess, yeah, m cross n grid, and in one operation what we can do is, like in this grid you can change value of any cell. So the grid contains digits from 0 to 9, and in any cell you can change the value. Okay, any cell you can change the value to any digit you want. And then what we want to do is we want to perform some operations on the grid. So now there are some constraints on how you can change the value of that cell. So the first constraint is that it should always be, let's say you're changing a particular cell, let's say you're changing a particular cell, then it should always be equal to this cell. So if you're changing this cell of the value of the cell to A, it should always be that case that this value is also A. So what that means is in a particular column, all these values in the grid will be A, right? So that's the first condition, equal to the cell below it. So this guy is equal to cell below it, this guy is equal to cell below it, and so on. So you can, so this is one constraint. Second constraint is that different from the cell to its right. Okay, so that means that if your value A over here, then in this cell you can only have B, and similarly for this you can only have a B, where A is not equal to B. And also these B's are the same coming from the first condition, right? And these A's are also the same. And then again, if you jump over here, you will have a C, which will say that C should not be equal to B. But yeah, but C can be equal to A. This can still be done. I mean, it can be depending on its next cell. So if there is no A over here, if there's an A, then C cannot be equal to it, obviously. So this is how we want to like construct our grid here. Okay. Oops. Yeah, I think I just did a control Z. Sorry about that. So yeah, so basically your grid will look like this: A, P, 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 C, 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 D, 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 right? Where A is not B, B is not C, C is not D. Just these conditions hold. And now you're given an initial state of the grid, and you have to calculate the minimum number of operations needed to convert it to this particular state, a state like this. Okay, so how to do this? So the first thing that comes to mind is to have some kind of a frequency thing going on and some greedy strategy. Those were my initial thoughts when I was thinking about it. So let's say you are, so I was just thinking through some examples here. Let's say you're given a grid like this: 5, 4, 3, 3, 4, 5, 5, 5, 5. Okay. So what I thought was that let's store the frequency of each element, the number of times it appears in each column. So here 5 appears 2 times, 3 appears 1 time. Here 4 appears 2 times, 5 appears 1 time. Here 5 appears 2 times, and 3 appears 1 time. In this column, in this column, and in this column. Okay. Then what I thought was that let's say there are n rows and m columns over here, right? And we can, at one instance, we can pick any of one of these elements only. Let's say I pick a 5, then I have to ensure that I don't pick a 5 over here. I can always pick a 4. And if I pick a 4, I can pick either of these, 3 or 5. Okay. So now for the picking operation, let's say I am analyzing this column, which is the first column of this grid. Let's say I pick a 5. There are 2 instances of 5 and 1 instance of 3. If I pick a 5, number of operations would be m n minus frequency of phi in that column, right? It's just saying that 3 minus 2 is 1. So I just need to change this 3 to 5. That's what we are doing. So number of operations is 1 in that case, if you want to make all the elements equal. Okay. So if you analyze this column by column for every column, let's say in the first thing you did, let's say you pick some number I1, okay, and then you went to the second column and you picked some number I2, where I1 can belong from 0 to 9, I2 can similarly belong from 0 to 9, and so on. Okay, so this is the first column, second column, mth column. There are m columns, right? So n minus fi, I don't know, fim. You have to find the minimum of all these values. Find the minimum over all i's. So this can belong from 0 to 9, this can belong from 0 to 9. And you have to also check a condition. If, let's say, you are picking a 1 over here, then you cannot pick a 1 over here again. You can like pick anything except apart from 1. Okay? So, I mean, this is kind of a standard dynamic programming problem where, let's say, our dp represents dp of I comma j will be minimum operations required till index I such that we pick number j at the ith index. Okay, so then the transitions are pretty straightforward. We just do dp of ij should be minimum of dp of ij itself. We want to store the answer, that's why, comma dp of I minus 1. So I went to the I minus 1 state and I picked some number k over there, right? And since I want to pick j in the ith column, index I means the column I, okay? This is the column. Since I want to pick j, the j number in the ith column, what I'll do is n minus frequency of j in column I. This is the frequency of number j in column I. Okay, that's all you're doing. That's all it is. So basically your j will go from 0 to 9 and your k will also go from 0 to 9. And you can obviously apply some memory optimization over here because the ith state is going from, it's only varying between I and I minus 1. So you can kind of do a mod 2 thing where you just store 2 instances, but that's fine. It's not needed for this problem. So the overall complexity would be, first you iterate over all the j's. Inside the j you will put in k, and your condition should be that j should not be equal to k. Only then you can apply this equation, right? Because in the I minus 1th column, if you're picking a k, in the ith column you're picking a j, then these two should not be equal. That's the only condition we have to apply. These two cannot be equal. So complexity would be the number of columns into 9 into 9. This is 81. So O of 81 times m. Let's jump into the code. So that's what I'm doing over here, just calculating the frequency. These are the columns, these are the rows. So for this particular ith column, I'm just incrementing the count of that number that it appears, how many times that number appears, as we saw in this example. This time I'm just then calculating my dp over here. Dp is just the first dimension is the column, second dimension is the digits. Okay, and all I'm applying is the equation that we just saw, and at the end I'm just calculating the answer. So now for calculating the answer, you will just see in the m minus 1th in the mth column you can have anything from 0 to 9. So what's the minimum answer? If you put each of them, you just calculate the minimum and you just return it. Yeah, so this was a standard DP problem, but yeah, it was kind of hidden to see this DP, and I think it was a good problem. Yeah. Moving on to the last problem, find edges in shortest paths. Okay, so this is Dijkstra, and what you're given is basically a graph like this where you have some edge weights, you have some nodes, and what we want to do is you want to go through a shortest path starting from 0 and ending at n minus 1. So there are n nodes. So there are 6 nodes in this case. So you want to go from 0 to 5, right? And you want to go through its shortest path, and you want to see, so now we are also given an array of edges, okay? And you want to see if an edge can lie on a shortest path or not. If an edge can lie on a shortest path or not. So for example, I'm given this graph, right? 0, 1, oops, 0, 1, 0, 2, 3, okay, wait, 0, 2, 3, 5, okay, 4, 1, 4. Okay, for the sake of simplicity, I'm just omitting this. Let's say 4, 1, these are the weights, and this is kind of 1, 1, 3. This is 1, 1, 3. So shortest path, and let's say this is 8 and 8, for example. So to reach from 0 to 5, the shortest path length is 5, right? You just travel like this. But you can also travel like this, right? 4 plus 1 is also 5. You can go from 0 to 2, 2 to 3, 3 to 5. That's one path. Second path is 4 plus 1, which is 5. And then in that case, this is also a varied edge in the shortest path. So 0 to 1, this edge also lies in shortest path. So what you want to do is, for every edge, you want to know if that edge will lie on the shortest path or not, on all the possible shortest path or not. Because this is one possible shortest path, this is the another possible shortest path. Okay, so how to do that? So I mean, you just have to apply Dijkstra twice over here. The idea is that, let's say you consider some edge with weight W, and let's say this is your 0 node, this is your n minus 1 node. There is some shortest path like this, dot 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 till here. Okay, this is your shortest path of length s, and you want to check if this particular edge lies in the shortest path or not. So what you want to do is, let's say the index of this edge is A, this index of this edge is B. So you want to calculate the distances of all the edges from 0, and also, distance of all the nodes from 0 and all the nodes from n minus 1. So what you will do is minimum distance to travel from 0 to A plus its weight plus minimum distance to travel from n minus 1 to B. Let's say this is your D1 array, this is your D2 array. So you calculate two distance array to travel from n minus 1 to all the nodes and 0 to all the nodes. Should be equal to, let me write it over here. Yeah, so this should be equal to S. And on the contrary, you can also do it like this. You can travel from 0 to B and then go to W, and then you go to D2 n minus 1 to A. So in the graph, this can also be equal to S. So if either of these conditions are true, then edge A to B is in the shortest path. That's all you want to check. Okay, that's all we want to check. And I mean, just apply Dijkstra once to calculate this, and Dijkstra second time to calculate this. And what it will look like or is that you can also go from 0 to B, and then from here, so it will like you go from 0 to B, travel from B to A, and from A to you go to n minus 1. So there are two ways to traverse. So you check for both these conditions. So moving on to the code, it's pretty simple code. Just convert the edges into a graph. Apply Dijkstra once over here to calculate all the shortest distances from 0, right? apply like is a second time to calculate all the shortest distances from n minus 1. And sorry, I was in a hurry, I couldn't name it better to d1 d2, so for now it's just assume d and d1. Okay, and the same thing we do over here. You take an answer for all the edges and just apply this condition. X2 is the weight of that edge basically. Then you just, if it's true, if either conditions is true, this answer index is true, and just return the answer. That's pretty much it. Hope you guys like the explanation, and see you soon. Like, share, subscribe, guys. Thank you so much.